Look around you. Touch the surface of the desk in front of you. Feel the weight of the air in your lungs. To our human senses, the world feels solid, dependable, and above all, permanent. We have built our civilizations on the assumption that the laws of physics are the bedrock of existence, an unshakable foundation that has remained constant for 13.8 billion years. But modern physics suggests that this sense of security is a profound cosmic illusion. We are not standing on bedrock. We are standing on thin ice, an infinitesimal layer of stability stretched over a fathomless abyss of chaos. And that ice is cracking. To understand the vacuum decay crisis, we must first dismantle our common sense understanding of nothingness. In the classical view, a vacuum is just an empty box, a space where you have removed every atom, every photon, and every stray particle until nothing remains. But in the realm of quantum field theory, there is no such thing as nothing. The invisible fluid of existence. Imagine the entire universe is filled with invisible fluids stacked on top of one another. One fluid is the electron field. Another is the electromagnetic field. Another is the Higgs field. These are the quantum fields. When you pluck one of these fluids, like a string on a guitar, a particle pops into existence. Pluck the electron field, and you get an electron. These fields aren't just background noise. They are the architects of reality. They dictate how strong gravity is, how fast light travels, and how tightly an atom's nucleus clings together. However, like any physical system, these fields seek the path of least resistance. They want to be at their lowest possible energy state. In physics, we call this state of minimum energy the vacuum state. For decades, we assumed our universe had already reached its basement. We assumed the fields had settled into their final, most stable configuration, the true vacuum. But as our measurements of the subatomic world have grown more precise, a terrifying possibility has emerged. We are living in a false vacuum, the ball on the plateau. Think of a mountain range. At the very bottom of the deepest valley lies the true vacuum, the state of absolute stability. Now, imagine a small, high-altitude plateau halfway up the mountain. On that plateau, there is a shallow dip, and inside that dip sits a ball. To the ball, life feels stable. It isn't moving. It feels like it's at the bottom because in its immediate vicinity, every direction leads upward. This is where our universe sits right now. All the laws of chemistry, biology, and physics that allow your heart to beat and stars to shine are predicated on the ball staying in that shallow dip on the plateau. But this stability is a lie. The ball is not at the bottom of the mountain. It is merely trapped by a small ridge. Beyond that ridge lays a much steeper drop leading to the true valley floor. If the ball ever nudges over that ridge, it won't just roll. It will plummet. This is the state of metastability. Our reality is stable-ish. It has lasted billions of years, yes, but it is not the final version of the universe. We are living in a temporary bubble of physics that is technically wrong, according to the fundamental balance of energy. The fragility of the normal. Why should this keep you awake at night? Because the normal we inhabit is surprisingly delicate. In our current false vacuum, the Higgs field, the field that gives particles mass, has a specific value. Because it has this value, electrons have the exact mass required to orbit atomic nuclei. Because those orbits are stable, atoms can bond into molecules. Because molecules exist, DNA can form. Because DNA forms, you exist. If the universe were to transition to the true vacuum, the Higgs field would change its value instantly. In a heartbeat, the rules of the universe would be rewritten. Electrons might become so heavy they collapse into the nucleus, or so light they fly away entirely. Atoms would simply disintegrate. The chemical bonds holding your cells together would vanish, not by exploding, but by simply ceasing to be a possibility of physics. We often worry about cosmic threats we can see coming, asteroids, solar flares, or the eventual heat death of the sun. But those are internal threats, events happening within the rules of the game. Vacuum decay is a threat to the game board itself. It is the realization that the stage upon which the entire drama of human history is performed is made of a material that could, theoretically, evaporate in a microsecond. The quantum nudge. The most disturbing part of this crisis is how the collapse begins. In our macroscopic world, if you want to move a ball over a ridge, you have to kick it. You need an input of energy. In the quantum world, however, there is a phenomenon called quantum tunneling. Subatomic particles don't always need to go over a hill. Sometimes they simply disappear from one side and reappear on the other. They tunnel through the barrier. There is a non-zero mathematical probability that, at any moment, in any coordinate of space, a tiny patch of the Higgs field will spontaneously tunnel through its energy barrier and settle into the true vacuum. It doesn't require a massive explosion or a black hole. It could happen in the empty space between your eyes as you read this sentence. It could happen in the cold void between galaxies. Once that tiny bubble of true vacuum forms, the ice of our reality doesn't just crack, it shatters. The true vacuum is at a lower energy state, which means it is more stable than the space around it. Like a drop of freezing water in a glass of supercooled liquid, the bubble will expand. It will turn the surrounding false vacuum into true vacuum, releasing a colossal amount of energy in the process. The silent horizon. This expansion happens at the speed of light. This is the ultimate no one is coming scenario. Because the wall of this vacuum bubble, the phase transition front, travels at c, the speed of light, no information can precede it. There would be no telescopic warning. There would be no frantic radio broadcasts from distant star systems. If a bubble of vacuum decay started at the Andromeda Galaxy 2 million years ago, the edge of that bubble would be reaching us right now. We wouldn't see it approaching because the light from the destruction and the destruction itself arrive at the exact same time. One moment, the universe is a place of stars, planets, and dreams. The next, it is a void where the very concept of matter is impossible. The cosmic lottery. We like to think of time as a long, continuous road. We plan for next year, next decade, next century. But Chapter 1 of the Vacuum Decay story teaches us that time is more like a series of coin flips. Every nanosecond, the universe rolls the dice on quantum tunneling. So far, for 13.8 billion years, the universe has lost the toss. The ball has stayed on the plateau. The ice has held. But the math doesn't lie. The stability of our world is a fluke of timing. We are essentially living in the moments between the lightning flash and the thunder. Except, in this case, the thunder is the sound of reality itself being deleted. As we move deeper into this exploration, we have to ask, what did we find at the Large Hadron Collider that made this theory so much more likely? Why are some physicists horrified by the mass of a single subatomic particle? The ice is thinner than we ever dared to imagine, and as we peer through the cracks, we start to realize that the vacuum decay crisis isn't a future problem. It is a fundamental property of the here and now. Reality is not a solid house. It is a flicker in the dark, and we are just beginning to understand how easily that flicker can be extinguished. In the summer of 2012, the world scientific community held its breath. Inside a circular tunnel 27 kilometers long, buried beneath the border of France and Switzerland, humanity was about to complete its map of the subatomic world. When the announcement finally came from CERN, the discovery of the Higgs boson, the atmosphere was one of triumph. Peter Higgs, the man who had predicted the particle nearly 50 years earlier, wiped tears from his eyes. It was the God particle, the final piece of the Standard Model. It was the anchor of existence. But as the initial euphoria faded, a group of theoretical physicists began to look closer at the data. They weren't looking at the victory. They were looking at the numbers. Specifically, they were looking at the mass of this new particle. And what they found wasn't a cause for celebration. It was a warning. In the quiet offices of institutes like Princeton and Max Planck, the mood shifted from triumph to a cold, clinical dread. They realized that the Higgs boson wasn't just the particle that gave us mass. It was the oh no particle. It was the messenger telling us that our universe was fundamentally broken. The cosmic thermostat. To understand why a single particle could be so terrifying, you have to understand what the Higgs field actually does. Imagine the universe is a giant swimming pool. Every other particle, electrons, quarks, photons, is swimming in this pool. The Higgs field is the water. Without this water, particles would have no mass. They would all be like photons, zipping around at the speed of light, unable to slow down long enough to clump together. No atoms, no stars, no people. The Higgs field is the cosmic glue that allows matter to exist in a structured form. But the Higgs field has a setting, much like a thermostat in a house. We live in a universe where the thermostat is set to a specific energy level. This level determines the strength of the nuclear forces and the weight of every atom in your body. For decades, physicists assumed this setting was permanent, that the dial was locked in place by the fundamental laws of nature. The discovery at the Large Hadron Collider, LHC, allowed us to finally measure the weight of the dial itself. And that weight told us something disturbing. The dial is loose. The stability map physicists use the mass of the Higgs boson and the mass of the top quark, the heaviest known elementary particle, to create what is essentially a life insurance map for the universe. This map is divided into 3 distinct zones: stable, unstable, and metastable. The stable zone. If the Higgs was heavy enough, our vacuum would be in its absolute lowest energy state. The ball would be at the bottom of the mountain, and nothing could ever move it. The universe would be safe forever. The unstable zone. If the Higgs was too light, the universe would have collapsed into a black hole or exploded into pure energy microseconds after the Big Bang. We wouldn't be here to discuss it. The metastable zone. This is the edge of the knife. It is a region where the universe is stable enough to last for billions of years, but it is technically in a false state. When the data from the LHC was plugged into the equations, the result was a bullseye. We are not in the stable zone. We are sitting squarely, precariously, in the metastable zone. The mass of the Higgs boson is approximately 125 gigaelectron volts. Combined with the top quark's mass, the math indicates that our vacuum is not the true vacuum. It is a temporary arrangement. We are living in a cosmic waiting room, and the door to the true reality is unlocked. The oh no moment. Why do physicists call this the oh no particle in private? Because the measurement was too perfect. If the Higgs had been just a few percent heavier, we could have slept soundly knowing the universe was eternal. But it chose the exact value required to make our existence a temporary fluke. This measurement revealed that the Higgs field is metastable, meaning it is currently resting in a shallow dip on a high hill. Imagine a dam holding back a massive reservoir of water. For 1,000 years, the dam has held. People have built cities in the valley below. They have forgotten the water is even there. But a surveyor arrives and realizes the dam isn't made of concrete. It's made of sand. It has held so far, but it is structurally destined to fail. The Higgs boson discovery was that surveyor. It told us that the potential of our universe is tilted. There is a lower energy state, a true vacuum, waiting for us. And because of the laws of quantum mechanics, if a lower energy state exists, the universe must eventually find it. The tunneling probability. This brings us back to the concept of the nudge. In classical physics, you need a massive amount of energy to break a dam. You would need to concentrate more energy than a supernova into a single point to push the Higgs field over its barrier. This gave scientists comfort for a long time. Surely, such an event is impossible. But the Higgs boson is a quantum particle, and quantum particles don't need a push. They can tunnel. The oh no realization is that the Higgs field is constantly sniffing the barrier. Every second, in every cubic centimeter of space, the field is essentially trying to tunnel through to the other side. The probability is incredibly low, so low that the average lifespan of a metastable vacuum is trillions upon trillions of times longer than the current age of the universe. However, low probability is not zero. In an infinite universe, or even a sufficiently large one, a low probability event becomes a mathematical certainty over enough time. The Higgs measurement tells us that the fuse is lit. It is a very, very long fuse, but it is burning. Why is the universe acting scary? There is a deeper, more philosophical dread associated with the Higgs discovery. Some physicists argue that the fact we are in the metastable zone is evidence of a multiverse. They suggest that billions of universes are born with different Higgs settings. Those in the unstable zone vanish instantly, and those in the stable zone might not have the right physics for life. We find ourselves in the metastable zone because it is the only place where complex chemistry, and therefore observers, can exist. But this offers little comfort. It means our existence is tied to the very instability that will eventually destroy us. We are like mold growing on a stick of dynamite. The same chemical properties that allow the mold to thrive are the ones that make the dynamite explosive. The Higgs boson discovery changed the tone of cosmology. We moved from asking how the universe will end, the big crunch, the big rip, to realizing that the end might already be written into the smallest vibrations of space. The silence of the particles. When the LHC shut down for upgrades after the Higgs discovery, there was a lingering sense of unease. We had found the particle that explains why things have weight, but in doing so, we found the crack in the foundation of the world. If the Higgs field were to slip to its true value, the mass of every particle would change. Protons would become heavier than neutrons. Atoms would dissolve into a soup of radiation. The oh no particle isn't just a discovery, it's a death warrant with a hidden date. We are living in the afterglow of a cosmic accident. The Higgs field is currently stuck in a state that allows us to exist. But the math says it won't stay stuck forever. In the next chapter, we look at what happens when the first bubble of that true reality finally breaks through the sand of the dam and begins its light-speed journey toward us. Reality is not what we thought it was. It is a temporary compromise between quantum forces, and the Higgs boson is the proof that the compromise is about to expire. If the Higgs boson is the messenger of our doom, then the bubble of nothingness is the executioner. In the previous chapters, we established that our universe is a false vacuum, a temporary plateau of physics resting precariously above a deeper, more stable reality. We know the ice is thin. We know the ball is perched on a ridge. But how exactly does the transition begin? What does the end of the world actually look like at the moment of impact? It begins with a single infinitesimal point of failure. It begins with the most terrifying phenomenon in quantum mechanics, the birth of a bubble that contains nothing we recognize as existence. The anatomy of a quantum leak. To visualize this, stop thinking of space as an empty stage and start thinking of it as a fabric under tension. Everywhere in the room you're sitting in, the Higgs field is vibrating at a specific frequency. This frequency is what we call our physics. It is the setting that allows gravity to pull and magnets to push. However, because of the laws of quantum uncertainty, these fields are never truly still. They are constantly jittering. Most of the time, these jitters are small and inconsequential. But in the vastness of the cosmos, across billions of light years of space and billions of years of time, there is a statistical certainty that a jitter will eventually be so extreme that it tunnels through the energy barrier. Imagine a pressurized steam pipe with a microscopic pinhole. For a long time, the pressure holds, but eventually that pinhole fails, and a jet of steam bursts through. In our universe, that leak is a bubble of true vacuum. Inside this bubble, the Higgs field has finally reached the bottom of the mountain. It has settled into its true vacuum state. To us, looking from the outside, this bubble would appear to be a sphere of absolute nothingness, not because it is empty, but because it contains a version of reality that is utterly incompatible with our own. Inside that bubble, the laws of physics have been rewritten. The wall of death, the moment this bubble appears, it is surrounded by the false vacuum of our universe. Because the true vacuum inside the bubble is a lower energy state than the space outside, it is more stable. Nature abhors an imbalance. The higher energy false vacuum immediately begins to collapse into the lower energy true vacuum. This causes the bubble to expand. It doesn't expand slowly. Driven by the immense energy difference between the two states, the walls of the bubble, the phase transition front, accelerate almost instantaneously to the speed of light. This is the wall of death. It is a spherical shell of concentrated energy that incinerates everything in its path. But incinerate is too mild a word. An explosion moves atoms around. The vacuum decay wall deletes the atoms themselves. As the wall passes through a star, the star doesn't just blow up. The nuclear forces holding its plasma together vanish. The star is unmade. As the wall passes through a planet, the solid rock is transfigured into a form of high-energy radiation that cannot support the existence of matter. The invisibility of the end. The most disturbing aspect of the bubble of nothingness is its absolute stealth. If a supernova occurs 100 light-years away, we see the light first, and the physical shockwave arrives much later. We have time to observe, to record, and to understand. But the bubble of nothingness travels at the speed of light. In physics, c is the cosmic speed limit. Information cannot travel faster than light. This means the news of the universe's destruction travels at the exact same speed as the destruction itself. There is no ahead of the bubble. If the bubble were currently 1 millimeter away from your left eye, your right eye would have no way of knowing. The photons carrying the image of the bubble's edge would hit your retina at the same microsecond that the bubble itself unmade your nervous system. You would not feel a chill. You would not see a flash. You would not hear a sound. The transition from existence to non-existence is instantaneous and total. One moment, you are a complex biological entity with thoughts, memories, and a future. The next, the space you occupy no longer supports the chemistry required for a single thought to form. You are not killed. You are simply no longer a part of the universe's equation. The physics of the interior. What is actually inside the bubble? This is where scientists move from dread into pure speculation. Some theories suggest the interior of the bubble is a singularity, a place of infinite density, where the universe essentially crashes like a computer program with a fatal error. In this scenario, the bubble is a void of literal nothingness, a hole in the fabric of space-time that leaves behind nothing but an eternal, featureless dark. However, other models suggest a more complex new reality. Inside the bubble, the Higgs field is at a lower energy state, which might allow for entirely new fundamental forces. Perhaps there is a supergravity or a dark electromagnetism. But there is a catch. The transition is so violent that any matter from our universe, any atom, any proton, is instantly converted into pure energy the moment it enters the bubble. If there is a new universe inside, it starts from scratch. It is a second Big Bang, but one that happens by eating the corpse of the old one. We are the fuel for a reality we will never see. The empty universe. Paradox. This leads us to a terrifying question. Has it already happened? Because the universe is so vast, a bubble of vacuum decay could have started 10 billion years ago in a galaxy on the other side of the observable horizon. It could be screaming toward us right now, having already devoured millions of civilizations, thousands of superclusters, and countless stars. The sky would look perfectly normal. The stars would twinkle. The galaxies would rotate. The wall of death is invisible because it is made of the very light that would otherwise carry its warning. We could be living in a ghost universe, a doomed sector of space that has already been deleted by a bubble, but the deletion just hasn't reached our coordinates yet. The fragility of the vacuum. Chapter 3 forces us to confront the ultimate existential horror. that the universe does not care about our progress. We often view time as a ladder, climbing toward higher intelligence and greater understanding. But the bubble of nothingness is the ultimate reset button. It doesn't matter how many books we write, how many planets we colonize, or how much peace we achieve. We are living inside a bubble of false vacuum that is under no obligation to persist. As we look toward Chapter 4, we will examine the speed of deletion and why the mathematics of the infinite makes this impossible event a statistical certainty. If the universe is infinite, then somewhere, at this very moment, a bubble of nothingness has just begun its journey. And in an infinite timeline, that bubble eventually reaches everyone. The thin ice of reality isn't just a metaphor for our fragility. It is a description of a physical boundary. And on the other side of that boundary, there is a version of the universe where we, and everything we have ever loved, never existed at all. The most unsettling aspect of cosmic catastrophe is usually the anticipation. We imagine the sky turning a bruised purple, the stars flickering out one by one, and the desperate, frantic broadcasts of a dying civilization. We imagine a countdown. But in the reality of vacuum decay, there is no countdown. There is no approaching storm. There is only the binary state of existence and non-existence. In this chapter, we explore the terrifying physics of the phase transition front, the wall of the bubble. We must confront the reality of a disaster that travels at the absolute speed limit of the universe, 299,792,458 meters per second. At this speed, the concept of warning becomes a physical impossibility. This is the speed of deletion, the absolute limit of causality. To understand why the speed of light, c, is so significant here, we have to look past the idea of light as just brightness. In physics, c is not just how fast a flashlight beam travels. It is the speed of causality. It is the maximum speed at which any event in one part of the universe can affect another part. Imagine you are standing on a planet 10 light years away from a star that suddenly explodes. For 10 years, you are perfectly safe. You can watch the star through your telescope, see it as it was a decade ago, and live your life. Then, exactly 10 years later, the light of the explosion reaches you, followed eventually by the physical debris. Vacuum decay is different, because the bubble's edge is a fundamental change in the fabric of space-time itself. It is propelled by the massive energy difference between the false and true vacuums. It accelerates to c almost instantly. This means the event and the information about the event are locked together. They are the same thing. If the bubble is coming for us, the light that would show us the bubble is part of the bubble's front. You cannot see the wave before it hits you because the seeing is carried by the wave. It is a silent, invisible executioner, the anatomy of the front. What is this wall of death actually made of? It isn't a wall of fire or a wall of lead. It is a topological defect in the Higgs field. Think of a piece of fabric that has been stretched too tight. In one spot, the fibers snap. That snap creates a tear that zips across the fabric. The edge of that tear is the phase transition front. On the outside of the front, the Higgs field is at its false value, the value that allows electrons to be light and atoms to be stable. On the inside, the field has dropped to its true value. As this front passes through matter, it doesn't hit it like a truck hitting a wall. It rewrites it. As the wall sweeps over an atom, the fundamental constants of physics within that atom change instantly. The binding energy that keeps the nucleus together might vanish. The electromagnetic force that keeps electrons in orbit might be recalibrated. In a fraction of a Planck second, the smallest unit of time, the atom is no longer an atom. It is converted into a spray of high-energy subatomic shrapnel. The no-warning paradox. We live in an age of surveillance. We track asteroids decades before they come near Earth. We monitor the sun for flares. We have developed a psychological dependence on the idea that we will know when the end is coming. The speed of deletion shatters this. If a vacuum decay bubble started at the center of our galaxy 26,000 years ago, it is reaching the edge of our solar system right now. But our most powerful telescopes, the James Webb, the Hubble, would see nothing. The Milky Way would look as majestic and serene as it always has. The astronomers at their desks would be checking their data, sipping coffee, and planning their next observation. There is no approaching shadow. There is no darkening of the stars. The stars behind the bubble are gone, but the light they emitted before they were deleted is still traveling toward us, just millimeters ahead of the wall of the bubble. We are looking at a sky full of ghosts, stars that may have been unmade thousands of years ago, but whose final funeral lights are still reaching our eyes. The moment of impact is the moment of realization, and the moment of realization is the moment of death. They are simultaneous. The galactic eraser. When we think of the speed of deletion on a galactic scale, the numbers become staggering. The Milky Way is about 100,000 light-years across. If a bubble started on one end, it would take 100,000 years to erase the galaxy. From a cosmic perspective, that is the blink of an eye. In those 100,000 years, millions of civilizations could be deleted. Thousands of star-forming nebulae, the nurseries of the universe, would be snuffed out. And because of the speed of light, none of these civilizations would ever know the others were dying. Each planet would feel as though it were the only one being hit. There would be no pan-galactic distress calls, no last messages to the cosmos. The speed of deletion ensures that every death in the universe from vacuum decay is a lonely one. The kinetic nightmare. While the bubble's wall is a change in the Higgs field, it also carries an incredible amount of energy. When the vacuum falls from a higher energy state to a lower one, the excess energy has to go somewhere. Physicists believe the wall of the bubble would be an intensely high-energy shell. This is the incineration aspect. Even if the change in physics didn't instantly unmake you, the sheer wall of radiation and heat, the latent heat of the vacuum, would vaporize anything in its path. This energy release further fuels the expansion. It's like a forest fire that creates its own wind, which in turn pushes the fire faster. The vacuum decay bubble is a self-sustaining, self-accelerating engine of destruction. It doesn't slow down as it hits matter. If anything, the matter it eats adds to the chaotic energy of the front, the psychological void. There is a unique kind of horror in the speed of deletion that differs from every other extinction event. In a nuclear war, there is a before and an after. There are survivors to mourn, records to be kept, and a history of the tragedy. With vacuum decay, there is no after. Because the destruction happens at the speed of light, and because it changes the fundamental laws of the universe, there is no possibility of a record surviving. No hard drive, no stone carving, no Voyager golden record can survive the transition into the true vacuum. When the speed of deletion reaches Earth, it doesn't just kill the human race. It deletes the fact that the human race ever existed. It unmasks the thin ice of our history, our music, our wars, our loves, and our scientific discoveries are all stored in the arrangement of atoms. When the bubble passes, those atoms are rearranged or destroyed. The information is gone. The universe is essentially formatted like a hard drive being wiped to zeros. The speed of deletion ensures that the new universe born inside the bubble has no memory of the old one. Living in the microsecond. In the end, Chapter 4 leaves us with a profound realization about our place in time. We are used to thinking of now as a stable, enduring moment. But now is actually a razor-thin line. Behind us is the past, which is fixed. Ahead of us is a future that we assume will happen. But between the two is the potential for the speed of deletion. We are constantly surfing the edge of a light-speed wave that hasn't hit us yet. Every second that passes where the laws of physics remain the same is a statistical miracle. We are living in the latency of the cosmos. We are the beneficiaries of the fact that the universe is so vast that even a light-speed disaster takes time to arrive. But, as we will see in Chapter 5, this time may be the very thing that explains why we feel so alone in the dark. The speed of deletion isn't just a threat to our future. It may be the secret history of our past. For decades, humanity has looked at the stars and asked a single, haunting question. Where is everybody? The universe is 13.8 billion years old. Our galaxy alone contains hundreds of billions of stars and presumably trillions of planets. Even if life is rare, the sheer mathematics of time and space suggests that the Milky Way should be teeming with radio signals, megastructures, and star-spanning empires. This is the Fermi paradox. We have come up with many excuses for the great silence. Maybe we are the first. Maybe civilizations hide. Or maybe space is simply too big to cross. But the discovery of the Higgs instability and the mechanics of vacuum decay offer a much darker solution. What if the universe is empty, not because life is rare, but because the universe itself is a lethal trap? What if vacuum decay is the great filter, the ultimate barrier that no civilization, no matter how advanced, can ever hope to surpass? The intelligence trap. The concept of a great filter suggests that there is a stage in the evolution of life that is nearly impossible to get past. It could be behind us, the transition from single-celled to multi-celled life. Or it could be ahead of us, nuclear war, climate collapse, or rogue AI. However, vacuum decay introduces a filter that is tied directly to the progress of science itself. To understand the universe, a civilization must probe its most fundamental parts. They must build particle accelerators. They must smash atoms together at higher and higher energies to uncover the secrets of the vacuum. There is a terrifying possibility that the more a civilization learns about the thin ice of reality, the more likely they are to accidentally break it. We already know that a sufficiently high-energy event, concentrating enough power into a single point, could theoretically trigger the nudge that pushes the Higgs field over the ridge. Is it possible that every advanced civilization eventually builds a final experiment? Machine so powerful that it inadvertently triggers a phase transition? If this is true, then the Fermi paradox isn't a mystery of biology. It's a symptom of a universe that deletes anyone who becomes smart enough to understand it. The great silence is the sound of billions of civilizations hitting the delete key at the exact moment they reached scientific maturity. The dead zone theory. We often assume the universe is a static map. We see a galaxy 50 million light years away and assume it's there. But, as we discussed in the Speed of Deletion, we only see the past. If vacuum decay is a common occurrence in a metastable universe, then the cosmos might be full of dead zones. These are vast bubbles of true vacuum, millions of light years wide, where physics has been rewritten. Because these bubbles expand at the speed of light, we can never see them coming. From our perspective, the universe looks pristine, but in reality, it could be a tattered remains of a much larger fabric. We might be living in one of the few remaining pockets of false vacuum, a small island of habitable physics surrounded by an ever-growing ocean of nothingness. The reason we don't hear other civilizations might be that they have already been consumed by bubbles triggered elsewhere, or by their own hubris. The safe energy limit. When the Large Hadron Collider was first turned on, there were fringe concerns that it might create a black hole or trigger a vacuum collapse. Mainstream science correctly pointed out that cosmic rays hit our atmosphere with far more energy than the LHC could ever produce, and the Earth is still here. This gave us confidence. But Chapter 5 asks, is there a limit? Nature produces high-energy collisions, but they are random and scattered. A civilization, however, might learn to focus that energy. They might attempt to engineer the vacuum itself to tap into the zero-point energy for infinite power. In doing so, they wouldn't just be observing the mountain. They would be drilling into the ridge that holds the ball in place. If the great filter is vacuum decay, then the universe has a built-in security system. Any species that attempts to reach a certain type on the Kardashev scale, a measure of a civilization's energy use, might automatically trigger its own extinction. The more energy you command, the closer you get to the oh no threshold, the loneliness of the metastable. This theory changes how we view our place in the cosmos. In a stable universe, we are a young species with an infinite future. In a metastable universe, we are passengers on a sinking ship who haven't noticed the water yet. If vacuum decay is the great filter, it means that the age of life in the universe is a temporary, local phenomenon. The universe wants to be in its true vacuum state. Our era, the era of stars, planets, and consciousness, is merely a chaotic, unstable transition period between the Big Bang and the final, eternal stillness of the true vacuum. Every civilization we hope to meet is trapped in the same waiting room as us. We are all waiting for the same light-speed wave to arrive. This creates a strange, existential solidarity. We are not alone because we are the only ones. We are alone because the universe is a minefield, and the lights are going out faster than we can find each other. The warning in the silence. There is a haunting thought experiment known as the estivation hypothesis. It suggests that advanced aliens are sleeping, waiting for the universe to cool down so they can process information more efficiently. But what if they aren't sleeping? What if they are hiding? if you knew that the vacuum was metastable, and you knew that any high-energy activity could potentially trigger a collapse, would you build a galactic empire? Or would you stay small, quiet, and low energy? Perhaps the great silence is a choice. The civilizations that survive are the ones that realize the danger and decide to stop progressing. They deliberately keep themselves in a technological dark age to avoid poking the Higgs field. In this scenario, the void isn't empty because life is gone. It's quiet because life is terrified. The inheritors of the void. When a bubble of true vacuum devours a civilization, it doesn't leave ruins. It doesn't leave Ozymandias statues in the sand. It leaves nothing. It is the ultimate cosmic censorship. This is why the filter is so great. Most filters leave a trace, a dead planet, a radioactive atmosphere, a broken Dyson sphere. But vacuum decay leaves a version of space where the civilization never could have existed in the first place. It erases the past along with the future. We look out at the void and see emptiness. We interpret that emptiness as a lack of life. But Chapter 5 suggests we should interpret it as a successful deletion. The void is not a desert. It is a graveyard where the headstones have been ground into dust by the laws of physics. Facing the filter. As we move towards the final chapter, we have to reconcile this great filter with our own desire to survive. If we are truly living on thin ice, does it make sense to keep walking? If scientific progress leads inevitably to the oh-no particle, then our quest for knowledge is a suicide mission. But humans are not a species that settles for staying small. We want to know. We want to see. The great filter of the void is the ultimate test of a civilization's character. Do we stop and survive in the dark, or do we keep turning on the lights until we accidentally set the house on fire? The universe is silent. Perhaps it is waiting for us to make the same mistake everyone else did. Or perhaps the bubble is already on its way, and our progress is just a way to pass the time until the speed of deletion finally catches up to our curiosity. We have spent the previous chapters contemplating the absolute annihilation of our reality. We have watched the wall of death move at the speed of light, unmaking the stars, the earth, and the very atoms that compose our memories. From our perspective, the perspective of the false vacuum, this is the ultimate tragedy. It is the end of history, the deletion of art, and the silencing of all life. But physics is rarely just a story of endings. In the grand, indifferent mathematics of the cosmos, a collapse is often just a reconfiguration. In this final chapter, we must step outside our human grief and look into the heart of the bubble. We must ask, what happens after the end? When the dust of our universe settles, if dust can even exist, what takes our place? This is the theory of the infinite reset. It suggests that vacuum decay is not a cosmic funeral, but a cosmic birth. We are not the protagonists of the universe. We are merely the beta testers for a reality that is far more permanent than our own. The alchemy of the void. To understand the aftermath, we have to look at the energy of the vacuum. In our universe, the vacuum has a latent heat. When the Higgs field drops from its metastable state to the true vacuum, it releases an unfathomable amount of energy. This isn't just an explosion. It is a phase transition, similar to how steam releases energy when it condenses into water. In the first trillionth of a second after the wall of death passes a point in space, that point is flooded with raw, unfiltered power. This energy is the reset. In many models of vacuum decay, this sudden influx of energy triggers a new inflationary period. Just as our own Big Bang began with a massive expansion of space driven by vacuum energy, the interior of a vacuum decay bubble could be the site of a brand new Big Bang. Inside the bubble, the laws of physics are rewritten. The settings of the universe, the strength of gravity, the charge of the electron, the number of spatial dimensions are all up for grabs. The old universe is the fuel for the new one. Our galaxies are ground down into the raw energy required to forge a different kind of matter. We are the compost of the cosmos, providing the nutrients for a reality we can never inhabit. The stability of the true reality. Why would the universe want to do this? In physics, systems always seek the state of lowest energy. Water flows downhill. Hot coffee cools to room temperature. Our universe, being metastable, is hot and high. It is an unnatural state of tension. The true vacuum is the state of absolute rest. Inside the bubble, the ice is no longer thin. The ball is no longer perched on a ridge. It has finally reached the floor of the valley. This means that whatever universe forms inside the bubble is, for all intents and purposes, immortal. It will not suffer from vacuum decay, because there is nowhere lower for it to fall. It is the final version of reality, while our universe is a flickering candle in a drafty room. The true vacuum is a sun that never sets. It is a terrifying thought that for 13.8 billion years we have been living in a pre-release version of existence, and the actual universe is only born when we are destroyed. The multiverse of bubbles. If we accept the infinite reset, we must view the cosmos as a vast, eternal ocean of foam. This is the eternal inflation model. In this view, space is constantly expanding and constantly decaying. Somewhere in the infinite distance, a bubble like ours once decayed and gave birth to the false vacuum we inhabit. Somewhere else, a bubble is currently decaying to give birth to a universe with 10 dimensions and no gravity. We are part of a recursive loop. The crisis we fear is merely a localized event in an infinite chain of resets. To an outside observer, someone standing in the bulk outside of our 3D space, the death of our galaxy would look like a tiny bubble appearing and expanding. In a glass of carbonated water, it is a minor chemical reaction in an infinite sea. The problem of information loss, the most painful part of the aftermath, is the censorship of history. In some versions of the Big Crunch theory, where the universe collapses and then bounces back, there is a chance that some information, some memory of the previous cycle, could survive in the form of gravitational waves or cosmic background radiation. But vacuum decay is a hard reset. Because the laws of physics change, the very alphabet used to write the history of our universe is destroyed. You cannot read a book written in English if the concept of letters no longer exists. You cannot remember a human face if the electromagnetic forces that held the neurons together have been replaced by something else. Inside the bubble, there is no evidence that we ever existed. There are no ruins of Earth. There are no derelict spacecraft. The new universe begins with a clean slate. This is the ultimate silent scientist theory. The reason we find no evidence of previous universes is that the transition to the true vacuum is so efficient that it leaves no witnesses and no evidence. It is the perfect crime. The philosophical oh no, as we reach the end of this journey, We have to grapple with a final disturbing possibility. If the true vacuum is the most stable and perfect state of the universe, why hasn't it happened everywhere yet? One theory is that we are simply early. We are living in the first few seconds of a cosmic drama that will last for trillions of years. But another, more chilling theory is that we are the anomaly. Perhaps life requires instability. Perhaps the true vacuum is so stable and so low energy that it cannot support complexity. In the perfect universe, there are no stars, no heat, and no movement. It is a crystalline, frozen perfection where nothing ever changes. If this is true, then our crisis is actually our gift. The thin ice is what allows the heat of life to exist. We are the friction in a machine that eventually wants to stop moving. The infinite reset isn't an upgrade. It's the universe finally finding the off switch. The final perspective. The acronium portal began by telling you that no one is coming. We have seen that the vacuum decay crisis is a silent, light-speed, inevitable consequence of the laws of physics as we understand them. But as we look at the aftermath, we see a different picture. We see that the universe is larger than our fears. If the bubble is coming, there is no way to stop it. There is no bunker deep enough and no spaceship fast enough. But there is a strange comfort in the math of the infinite reset. It tells us that we are a part of something that does not end. Even if we, the humans, the Earth, the Milky Way, are deleted, the process of existence continues. The energy that currently makes up your heart and your mind will not vanish. It will be the Big Bang for a new world. You will be the light of a star that humans could never imagine. You will be the foundation of a reality that will never know fear because it will never know instability. The doorway in the dark, we end where we started, looking at the Higgs Boson. That tiny, oh-no particle is a key. It unlocks the door to the realization that we are temporary. But being temporary isn't the same as being meaningless. A song is temporary, but it has beauty. A sunset is temporary, but it is real. Our false vacuum is a 13.8 billion-year-old song that the universe is singing to itself. Eventually the song will end, and a new one will begin. The vacuum decay crisis isn't a problem to be solved. It is the final sentence of our chapter. And while we may be horrified by the scale of the destruction, we can also be amazed by the scale of the rebirth. The universe is acting scary because it is changing. It is approaching the end of its first act. And as the curtain falls on the false vacuum, we can take one last look at the stars and realize that even in the silence, even in the nothingness, the story never truly ends. It just resets.